Hello, friends. Welcome to another day of the AI Developer course where we are spending 5 to 10 minutes writing code to learn one small AI concept every day. We are in Module 1 and we are learning on the basics of LLM, prompting techniques, and context engineering. Let's have a look at today's micro build task. We want to use prompting to create a context compression technique that helps us significantly reduce the size of text but preserves the critical context. All right, let's get to it. I would recommend pausing the video here and trying to write this code yourself before looking at the solution. All the micro builds are designed to be able to be done within 5 to 10 minutes. So please give it a shot before moving ahead. All right, so let's get to it. We want to create a compression technique and we want to use prompting for that. For this particular task, I have downloaded a 500 word essay on Elon Musk, and our goal will be to compress it into 50 to 60 words, but preserve all of the critical context in the essay. This task is quite useful for real applications like article summarization, blog summarization, etc. It can also be a good technique to just reduce the size of context that you would need to pass to a LLM. Hence, can help you reduce token size. Let's get to let's get to the code. For this particular code, I'm using a technique called chain of density. This was a paper published in 2023, and it's the link to the paper is linked in the comments. The code link will be in the video description. So, what chain of density does is it starts with a more vague content with the word that we want, and then it tries to look back to the article and it tries to identify the missing entities in the generated text from the original article or the ground truth, and it will add those critical entities to the text, and then we will iterate a few times over that, and it will keep on per iteration, it will keep on identifying new information that was there in the ground truth or the original article but was missing in the generated content, and it will keep on doing that. Every iteration will make the generated content more dense and more rich with the information that we've got. So let's have a look at it. The code is pretty straightforward. We are again using Anthropic for this particular task. We have made sure that our API key is there in the environment. We've got a utility function that is basically loading this article for Elon. And here is our prompt. We are passing the whole article to the prompt as is, and we have got a prompt asking it to look at the article, repeat it for X number of iterations, and identify information that was missing in the generated content from the article. We've also defined what a missing entity means. So, it is picking the right uh, relevant information instead of something that might not be as useful for the article. You should play with this prompt and you should just see how the variation of the prompt results in a different kind of article. All right. Okay. Let's run it and let's just see how how it works. So this run is taking a bit of time because the iterations are happening on the LLM end, and it returns everything in a chunk. Once everything is returned, it returns it in a particular JSON format where we have asked it to provide us all of the entities as a list. So that's why it took a bit of time, but it was the LLM trying to process it. But let's have a look at what it gave us back. So it compressed it to 78 words. We asked it to compress it to 80 words. So it did pretty good job there. If you look at the summary, the first it's trying to identify things that was not there in the article, and it is trying to include this new identified information into the generated text. It goes on the next cycle. It realizes, oh, I did not have PayPal or Starlink in it, and again it goes ahead and includes that in the generated content. Keeps on repeating, keeps on looking for more information in the ground truth, and keeps on enriching this text that you've got. So instead of taking a text that is already rich and stripping it off, it's doing the opposite. It's starting with something that is a bit vague and open ended and stripped off, and is incrementally adding more and more relevant or interesting information in the generated text. And once you get to the fifth iteration, you say it is pretty much fact, right? So this is another interesting thing. If you are generating this content to serve to a user, you might want to find what's a good balance here of the factual information versus what we call is the creative writing, right? So you might just need to find maybe iteration 3 or iteration 4 gives you that balance where it's not too dense for your audience, but it preserves all the information. If you are generating a technical report, though, you might just want as concise and as much data and information as possible. In that case, you might lean towards having higher iterations there. That's all for the micro bill. This is a new technique. There are many other advanced prompting techniques. This is just one of those. Use your time to research other prompting techniques, write some code, play around with the prompt, and see how the output is different for the changes in the prompt that you've made. Another interesting way is right now the LLM was doing all of the iteration of its own end. What if you would have done 5 individual LLM calls and tried to do the iteration outside of the LLM? Would the result be different? Something you should play around with. That's it, friends. So, as part of this micro build, we learned about advanced prompting techniques, context compression, and summarization. Uh, like I said, there are many other advanced prompting techniques. This is one of them. Hopefully, it is a pathway for you to start exploring other advanced prompting techniques. See you again next time for the next micro build. Thanks.